Okay, so today we'll be talking about velocity, just only velocity in this video. So I'll talk about everything relating to velocity. So the first of all, I'll be talking about the definition of velocity. Then I'll go with differentiate velocity from speed, and also explain velocity in terms of a displacement and time. Discuss the vector nature of velocity and provide some example of velocity. Yeah, I think that will give us better definition of it. So better good understanding. So in a more simpler term, like in a more basic general term, to define velocity, I would say velocity is just speed with direction. Oh, let me just start with speed. Speed is just when you say what is speed, I think everybody know that just how fast they are moving. So speed is literally talking about how fast they are moving. So it has nothing like relating, like you're not relating anything. So speed is just how fast they are moving. But now velocity, we all know like velocity is kind of like synonymous to speed also. So the main difference between velocity and speed is just that how fast they are moving in a specified direction. For example, now, I want to go to maybe Ikeja City Mall to like buy something. Okay, how fast am I going? How fast am I moving towards Ikeja City Mall? Or I don't know when guys like when we're little, like when our mom come back from market, then all of us simply want to run towards our mom. So the fastest of all, the fastest of us will get to our first. But what we are relating there is not velocity because we are moving like towards our mom because we have a specified direction we are going. We're not just running up and down without us heading. Like little children or ants, if you see like maybe just running around for just for fun, but without a specified direction. But then when you're moving towards a place or moving towards something like, oh, I want to go to this place, and you're moving like as provided you're moving, even if you're not that fast, provided you're moving, you have definitely a speed. But then you're not moving with like going to a place that you want to, or you have defined a place you are going to. So refer to that one as velocity. Talking about direction, that's the direction we're referring to. Okay, I want to visit my friend at maybe Soka area. I think that is Atibadan. Okay, I want to visit my friend at Soka area. I can leave like in the morning and start jogging. So I can be jogging like 1 meter per second. But provided like I have this like a definite place I'm going. So I'm going to like the direction I'm going, okay, I'll have to pass through this street. So provided like I define my direction, or I'm not just walking zigzag. I have like a specified path I want to take. Refer to it as velocity. So that's just the difference. So speed is just like talking about how fast like an object is moving. That is just like general term. But now when you have like when you now have a direction that you are going to, or you have a place that you are going to, refer to it then as velocity. So the next one I'll be talking, I'll differentiate between velocity and speed. So the next one I'll be going is explain velocity. Okay. Um okay, now we just highlight the differences between velocity and speed. So the first one is the magnitude. So for speed we just have distance over time. So that's how we just find the magnitude for like speed. That's just the formula, distance over time speed. That's how you find it. For velocity we say displacement over time. Yeah. So the other one is in terms of direction. Speed, as I said earlier, speed does not have a specified direction. You're just moving. Just know you're moving. So yeah, that's speed. It has no direction. So why for velocity it has a specified direction. So and also we can put this speed is a scalar quantity and velocity is a vector quantity also. Yeah. Okay, I'm going to show you my note. I think you should be able to see this. So that's the formula for both speed and velocity. I think it should be like clear a bit. Yeah. So okay, so that will be the first question for velocity. Let's say if a car travel 10 kilometers north in 30 minutes, what is its velocity? So if we should analyze that question like together, first of all, the first thing we realize they give us 10 kilometer and we know 10 kilometer is distance. Absolutely distance. So it's only distance you measure in kilometer, miles, yeah, meter, centimeter, all has to do with distance. Especially when you're traveling, I think you can say something like 10 kilometer ahead, 200 kilometer ahead. So just that is distance. So remember, now say 10 kilometer north. So now this is trying to tell us we're talking about velocity because it's traveling in a specified direction. It's traveling due north. I think if you still remember bearing in mathematics, but let's just leave that aside. So it's talking about it's traveling north. So it's traveling in a specified direction. So they now said in 30 minutes, what is its velocity? What is its and yeah, kilometer for one to find out velocity that will be kilometer per hour, so they give us 30 minutes. So what we'll just do is convert our minutes to hour. So 30 minutes is half an hour. That's the same thing as 0.5 hour. So in altogether that'll be 10 kilometer divided by 0.5, giving us 20 kilometer altogether. So that will be the answer, or that will be the velocity. I think that's a good example for solving some question relating to velocity. Okay, so this is my book. So the first one is I think you can see my distance, 10 kilometer, and then I'm going to write for my time, which they gave us as 30 minutes, and it's the same thing as um 0.5 hour. So there's it. So you can see the two 30 minutes seems as 0.5 hour. Can remember the formula for our velocity, which is you can put displacement here. I put distance, yeah. So it's the distance is the displacement because it's specified direction. So that's our displacement displacement over time. So yeah, there's it. And then we'll give 10 divided by 0.5, giving us 20 kilometer per hour. So yeah, there's it. Could be our final answer, 20 kilometer per hour. I think this should be kind of clear a little bit. So yeah, very simple. This is like kind of like the simplest question they can give you relating to velocity and time. Okay, so okay, so this other question that a cyclist travel 20 kilometer in 1 hour and return back to the starting point in another 1 hour. What is the magnitude of his velocity? So now, when you hear the word like magnitude, just take it like this. Let me put like a simpler term. It's just talking about, okay, maybe this way the thing start, how big like a 10 is. So that's what our magnitude. You can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can just put that as magnitude. So in this question, a cyclist traveled 20 kilometer in 1 hour. Okay, let's say, okay, this is like the cycle started from here and then moved 20 kilometer in 1 hour. I did not say return back to the starting point in another 1 hour. So it went up and then went back again to this where it started from again. I mean, this top of my palm, and it returned back to the top of my palm again. Then I say, what is the magnitude of its velocity? So in this kind of question, I think what most people will do is that they'll add 20 plus 20. That would be like the total distance cover is on 40. Yeah, that's true, 40 kilometer, and then he spent a total of 2 hours. Absolutely correct. So we now say the velocity will be 20 kilometer per hour, but that will be wrong. But in speed, that will be like the answer for speed. But in this case, the answer will be zero. The magnitude in this place is zero because magnitude is just talking about how far. Remember the question, the cyclist went up and still went back again, or it traveled like okay, let me put my hand like this. So it traveled 20 kilometers, also went back again to a starting point, making it zero. It's like it's never moved. The cyclist never even move from the starting point. So that's why for this thing, you don't need no workings for it. The answer is just clearly zero because it's just magnitude. And when it travel 20 kilometers, it also return back again to the starting of that point again, or where it begin, or his journey, is starting off his journey again. So that was why for this question it's going to be zero. No solving, no nothing. So magnitude is literally talking about number, or talking about, yeah, when you hear the word magnitude, just talking about how big, and just making it generic understanding. So magnitude just talk about, okay, how big, or how like or let me put it like okay, Another way I can explain magnitude, we'll put it this way. Just imagine, okay, while all students are feeding up, each month they were being credited 100,000. Yeah. Or before we're credited, we're at zero, right? We don't have money in our feeding app. So then they credit us, and then we have 100,000. Yeah, because that would be like the highest. So the same thing in this like example now. This cyclist has like he traveled 20 kilometers in 1 hour. So we'll take it as when it was credited is 100,000 naira. Remember now we know that at the ending of the month, definitely what will be the money remaining in our feeding app? Probably zero again. So that's just it again because it went up, he spent because we are spending the money. That's the same way when it starts returning back to a starting point. It will start to like cover the distance already, like it's returning back to where it started before. The same way we are spending our money. So that's like why the cycle is like kind of coming back again. You can just take it in that kind of scenario. So the magnitude is not like getting zero because it's returning back to where it initially started from. The same way when you're spending your money from your feeding app, you're going to return back again to zero. Or when you say like if you spend more than you earn, you're going to become poor again. So that's the same thing because the cyclist is returning back to where it started from. That's why his magnitude is zero. It returned back again. It didn't like go further or move further from where it started. As you move forward further from where it started, it would have been zero. I hope I'll be able to explain this question. Yeah. Okay. So this question is like it's the simplest of all questions, which is if a train travels 200 meter east in 20 seconds, what is its velocity? Okay, I think you can pause this video and then solve it yourself. I think you should get it in like less than a seconds. Okay, so our first point I will mark out is the distance the train travel, which is 200 meter. 200 meter, and then the time is 20 seconds. So that will be like our true mating. So we can proceed to like the formula. Writing velocity is displacement over time. Let me write it out and then show you. um I shorten my displacement something though, so that because of time and my ink is expensive now. So our displacement was 200 divided by 20. So we get this in total. That will be 10 meter per seconds. If you get that answer, you're absolutely correct. That'll be 200 divided by 20, giving us a total of 10 meter per seconds. I think my book should be like clear a little bit. Yeah. So that would be like I think the most simplest question you can ever say in this kind of topic though, but believe me, actually very simple though. Okay, so the vector nature, just talk about the vector nature of velocity. You see, velocity is a vector quantity, and the last time I differentiate this distance and displacement. Okay, let me just talk about that displacement first. Displacement is a distance also. So, and we say that this. Okay, let me just turn to this like back of my book. So now we can say like the distance from here to Ibadan. Okay, if I'm traveling from Lagos to Ibadan, definitely I'm going to like crossroad. I'm going to bend, maybe pass bridge, and then maybe like have to pass through roundabout again, and then if I get there. So that's referred to as distance because the place or like the point between your house and Ibadan, because you have to turn. It's not like a straight line. Refer to it as distance. So displacement is like, just put it this simpler terms, just straight line. Especially when you travel with plane, those plane they always travel in a specified like path or in a straight line. So when the thing is like kind of like straight, or when the path you are taking is straight, just know that it's displacement. Just put it that way. But the definition is like displacement is distance traveled in a specified direction. But you can take it as distance in a straight line. It's also displacement. Just put in when your distance between two places you're traveling to is in a straight line, take it as displacement. But when the thing is now becoming curvy, or you're having kind of like a curved line, no longer straight anymore again, is distance. But once you're having like something straight, travel like maybe like this pen, just traveling straight from like this tip of my pen to the other end, is displacement because the line is straight. You can put it that way. Yeah. So as I said before, velocity is a vector quantity because vector quantity in itself is just talking about things that have to do with direction, that is vector quantity. Anytime you have to do that have to do with direction is a vector quantity. So that was why velocity is a vector quantity, because of displacement present. So it's actually referring to a direction. I'm traveling 100 kilometers due east. I'm traveling at an angle 60 degree. I'm traveling from here to maybe somebody's house. It's specified direction also. So provided that the direction is specified, it's referred to as vector quantity. And speed is a scalar quantity because you're not referring to any direction. You're just moving on your own. You don't care about which space you are going to. You're just moving. Busybody, like devil that is walking to and fro. Okay, so yeah, that was scalar quantity, talking about something that does not have direction. So that is the difference between scalar and vector. So that was why velocity is a vector quantity, because it has to do with a specified direction. Why for speed is a scalar quantity, because it does not have any direction. It's just moving on its own. So yeah, that's it. That'll be the end for this section.